All right, here's a review for the final exam in pre-calculus. All right, so let's get started. I wasn't able to work every single question because there was a bunch. I just picked out the ones that were chosen the most. All right, test 1, problem number 6. It says negate the following statement. There exists a real number y such that for every real number x plus y equals 5. Well, remember, there exists, to negate that, it's for all. And then here it says for every real number, so to negate that, that would be there exists. So, to negate it, it would be for all real numbers y, there exists x such that x plus y does not equal 5, because see here it says equals 5. So that would be the negation of that one. All right, problem from test 2. Problem number 3, they want us to find the inverse of this function. All right, so this would be, well, we have to change the f of x to y. All right, and then you swap the x's and y's, so we get x equals 2y plus 1 over y minus 3. And then we just solve for y. So you can look at this as two fractions equal to each other. So we can cross multiply. So that's going to be x times y minus 3 equals 1 times 2y plus 1. Clear the parentheses, we get xy minus 3x equals 2y plus 1. And then we want to get all the x's on one side and all the y's on one side. So what I'm going to do here is I'm going to add 3x to both sides, and I'm going to subtract 2y to both sides. And so this is going to give me xy minus 2y equals 3x plus 1. And then notice here how we have a common factor of y. I can factor that out. So y times x minus 2 equals 3x plus 1. And then we'll divide both sides by x minus 2. Y equals 3x plus 1 over x minus 2. And then we change the y to f prime of x. Not f prime, but f inverse. 3x plus 1 over x minus 2. And this would be your answer. All right. All right, another question that got asked a lot on test number 2 is this one we want to solve. So we've got two radicals here. So in order to solve this, we want to isolate one of the radicals. All right. And so that's going to give us the square root of x plus 8 is equal to the square root of x minus 4 plus 2. All right. And then we want to square both sides. And so that's going to give us x plus 8 equals. Now, for this one, this is going to be the square root of x minus 4 plus 2 times the square root of x minus 4 plus 2. And then we've got to FOIL that. So we get x plus 8 equals, so we multiply the first, that's going to be x minus 4, square root of x minus 4 times square root of x minus 4 is x minus 4. And then we multiply the outside, so that's plus 2 square root of x minus 4. Multiply the inside, plus 2 square root of x minus 4. And then the last, that would be plus 4. And so we get x plus 8 is equal to x. And then let's see, the 4's, they go out, that's 0. So plus 4 square root of x minus 4. All right. All right, so now let's subtract x to both sides. And that is going to leave us with 8 is equal to 4 square root of x minus 4. And then we can divide both sides by 4. And so I'm going to come up here. That's going to give us 2 equals the square root of x minus 4. And then we're going to square both sides. And that's going to leave me with 4 is equal to x minus 4. Add 4 to both sides, x equals 8. All right. Now, for this problem, okay, we get x equal 8, but we do have to check our solution. So remember, you've got to come up here and check. So we got to take the 8 and plug it in for x. So that's the square root of 8 plus 8 minus the square root of 8 minus 4. And we want to know, does that equal 2? So this is going to be square root of 16 minus square root of 4. Does that equal 2? Square root of 16 is 4. Square root of 4 is 2. And we get 2 equals 2. That checks. So x equal 8 is a solution. All right. All right, let's look at test 3. All right, so we want a graph. So basically what we're going to do here is kind of sketch the graphs and label the x and y intercepts, okay? So the first thing we want to do is we want to get the zeros. So we want to know, when does negative x minus 1 squared times x plus 2 equal 0? Well, that's when x minus 1 equals 0 or x plus 2 equals 0. And so x equal 1 or x equal negative 2. So these are your x-intercepts at negative 2, 0 and at 1, 0. And then, so these are your x-intercepts. Now, if we look at the y-intercept, we plug 0 in for x. So we get f of 0 is equal to negative 0 minus 1 squared times 0 plus 2. And this is going to give us negative 2. So we've got a y-intercept at 0, negative 2. And so what we're going to do, we're going to come over here and just kind of sketch this out. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so we're going to plot the point negative 2, 0, 1, 0, and then we got 0, negative 2. All right, so what we got to do now is we're going to look at end behavior. So what happens as x, let's see, where can I write that? Let's write it here. As x goes to negative infinity, f of x goes to what? So x is going to negative infinity. Okay, so the largest, the degree of this function here is 3, because if we take x minus 1 and we multiply that out, we're going to have an x squared. And then when we multiply it by this term, that's going to give us an x cubed. So x cubed raised to a negative number is negative. And then we got the negative out in front here, which is going to make it positive. So f of x would go to infinity. And then as x goes to positive infinity, f of x is going to what? Well, once again, a cubed. If we multiply all this out, that's going to give us a cubed. An x cubed is going to be the largest power. So if we take a positive number, raise it to the third, that's going to be positive. And then we got the negative in front, so that's going to go to negative infinity. So we know as we come this way, as we're going to negative infinity, the graph's going to increase. It's going to go to infinity. So it's going to look something like this. And then it's going to come down here somewhere. Okay, we're not really that concerned about finding exactly where it turns back up. just to get a sketch of it. It's going to come up and it's going to come back through the y-intercept, and then it's going to increase. But notice, once we're going to infinity over here, the graph, the y values are going to negative infinity. So once it gets here, it's going to turn back down like this, and the graph's going to look like that. And we know it's going to hit this point and turn because of that squared term there. Okay, but there's the graph of it. Okay, this would be -2, that's 1, and this is a y value of -2. All right, let's look at the next one. Here's another one. Went ahead and worked this one because this is a pretty good problem. We've got to actually solve this one. So we need the p-values. So remember, your p-values are factors of the constant over here. So that's going to be plus minus 1, plus minus 2, plus minus 4, and plus or minus 8. And then our q values are going to be factors of the coefficient of your leading term. So 1 is in front of x cubed. So that's just going to be plus or minus 1. And then we look at p over q. Well, that's going to be this over this, the 2 over this, the 4 over this, and the 8 over this. So that's going to be plus or minus 1, plus or minus 2 over 1, which is just 2, plus or minus 4 over 1, which is just plus or minus 4, and plus or minus 8 over 1, which is just 8. And so now we're going to use synthetic division to see which one is a 0. And so let's just try the 1. All right. And then we got 1, 2, 4, 8. So the 1 comes down. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 4 plus 3 is 7. 1 times 7 is 7. 8 plus 7 is 15. That's your remainder. So the 1 does not work. And we can try the -1 and so on, and the 2. Let's try the -2. Okay, let's do -2. We got 1, 2, 4, and 8. So the 1 comes down. -2 times 1 is -2. That's 0. -2 times 0 is 0. 4 plus 0 is 4. -2 times 4 is -8. 8 plus -8 is 0. There's your remainder. So remember, this variable, this coefficient is with the x cubed. So that means this one down here is going to be x squared. So that's x squared plus 4. And so if we go to factor this thing, that's going to be x plus 2 times x squared plus 4 equals 0. If we set that equal to 0. Remember, the -2 is a solution. So what would that be? That would be x plus 2. See, when x plus 2 equals 0, x is equal to -2. That's where the x plus 2 comes from this minus 2 here. And then that's times the x squared plus 0x plus 4, our constant. All right. Well, notice this will never be 0, because if you go to solve this, you're going to get x squared equals -4. You would get x is equal to plus or minus 2i, an imaginary number. Okay, and you can't have that. All right. So now that we've done all that, I'm going to erase this so we can come up here and draw the graph. So we got here and here. So we've got 1, 2. So that's -2. That's the x-intercept. All right. And now to get our y-intercept, let's come down here, y-intercept. That's just when the function is equal to 0. So if you plug 0 into this thing, you can see all of those are 0, and we would be left with 8. And so that would be, we'll just call that 8 right there. So this is our x-intercept, and this is our y-intercept. All right, now let's look at our end behavior. All right, let's see where that graph's going. And so we can see as x goes to -infinity, f of x is going to what? Well, as x is going to negative infinity, well, we just got to look at the leading term. We don't care about anything behind it. If we take a negative number and raise it to the third power, we're going to get a negative. So this is going to go to negative infinity. And then as x goes to positive infinity, f of x is going to what? Well, if we take a positive number and raise it to the third power, that's going to be a positive. So this is going to positive infinity. So what this graph is going to look like, it's going to look something like this. And it's going to look like that. See, it's going to negative infinity as x goes to negative infinity, and it's going to positive infinity as x goes to positive infinity. And so there's your graph right there. All right. Test number 4. All right, so let's see what we can do with this problem. So this is a proof. We're doing proof by induction. So it says prove the following statement. All right. So we have to show that it's true for n equals 1, right? We got to show it's true for that. So we do the sum I equals 1 to 1. And so i's going from 1 to 1. We just plug the 1 in for I. And then we got to plug the 1 in for n right here. So that's going to be 1 times 2 over 2, which is 1. So they both equal 1. Okay. And then we assume it's true for n equals k. So in other words, we're assuming it's true. I equals all right, so notice I didn't fill this out up here. Okay, so this is where you've got to watch. This is going to be I equals 1 to k. I equals 1 to k. I was having a little trouble writing that k. It didn't want to write it. All right, so we assume it's true for that. And then, we want to show true for n equals k plus 1. So we got sum I equals 1 to k plus 1 of I is equal to, well, that's the sum of I equals 1 to k of I plus k plus 1. All right, so let me show you where that comes from. So if you look at this, if you look at the sum, now this isn't part of the work on the problem, so I'll do it in a different color. So if you look at sum I equals 1 to k plus I to k plus 1 of I, that's equal to 1. So we plug in the 1, then we plug in a 2, then we plug in a 3, and so on, all the way to this last one, this k plus 1, right? Well, what would come right before k plus 1? Well, that would be k, right? And so if you look at this, see this 1 plus 2 plus 3 plus k? Well, that's just this thing. That's where that comes from, this. Okay? And then we have to put the k plus 1 term because we're going to k plus 1. But I just split this up into the sum I equals 1 to k and then the last term k plus 1. All right. And so now this is equal to k times k plus 1 over 2 plus k plus 1. All right, so where did that come from? Well, you see this sum I equals 1 to k of I. Where is it? That's this. That comes from right here. See, we assume that's true. So I'm replacing this with k times k plus 1 over 2. And so now, if I look at this, this is going to be k times k plus 1 over 2 plus, we're getting a common denominator, right? Common denominator of 2, okay? And then this is going to be k times k plus 1 plus 2 times k plus 1 over 2. And now I'm going to factor out. You see how I have a common factor of k plus 1? I'm going to factor that out. K plus 1 times, and then k plus 2. Whoops. K plus 2 over 2. See, when I factor out the k plus 1, I'm left with k plus 2. And then this is k plus 1 times k plus 1 plus 1. I just broke the 2 into 1 plus 1. And then you can see that, let's see. Well, I didn't write it down up here. But we want to show that it's true for, now let me write this. That's sum I equals 1 to k plus 1 of I is equal to k plus 1 times k plus 1 plus 1 over 2. See? So what I did here is I'm replacing the ends with k plus 1. And so I should have written this first, and I just didn't. But this is what we want to prove. And so you go through all this, and you can see that we ended up with that. All right. All right, so now we're on to test 5, problem number 9. They want us to solve this. So remember, anytime you're solving a exponential equation, you want to try to get the bases the same. If you can't get the bases the same, like we can't here because we got a base of 3 and a base of 5, you want to take the natural log of both sides. All right, and so then we have a property from logarithms that says we can take the exponent and pull it down in front of the log. All right, and then here we're going to do the distributive property. So that's x times natural log 3 plus natural log 3 equals x natural log 5. And so what I'm going to do here is I'm going to subtract x natural log 5 to both sides. All right, because I want to get all the x's on one side, and I'm going to subtract natural log 3 to both sides. And so you can see that those are going to cancel out and those are going to cancel out. So I'm left with x natural log 3 minus x natural log 5 equals negative natural log 3. And then I have a common factor of x. I can factor that out. Natural log 3 minus natural log 5 equals negative natural log 3. And so divide both sides by this. X is negative natural log 3 over natural log 3 minus natural log 5. And that's leaving it in it as an exact answer. All right. Test 6, we want to graph this. Y equals sine of x minus pi over 4. All right, so what we want to do is we know the basic shape of the graph of sine. So we want to take the x minus pi over 4 and put it between 0 and 2 pi and solve for x. So I'm going to add pi over 4 to all three parts. And so this is going to give me pi over 4 is less than or equal to x, less than or equal to, what is that, 9 pi over 4. All right. So we've got pi over 4, and we've got 9 pi over 4. That's the interval we're going to graph it over. And this is 1, and this is negative 1. So we know the amplitude, the amplitude is 1. All right. The period is 2 pi over b. Remember, b is the number in front of x, so that's 2 pi over 1, which is 2 pi. And then the phase shift is, now remember, when you solve this, this is your phase shift. That's pi over 4. Okay? So it's going to shift pi over 4 units to the right. All right, so now to graph this, we have to split this up into equal intervals. So we need the midpoint between pi over 4 and 9 pi over 4. So if we take pi over 4 plus 9 pi over 4, that is equal to 10 pi over 4. And then if we take the 10 pi over 4 and multiply it by half, that's going to give us 5 pi over 4. So this would be 5 pi over 4. And then we need the midpoint here. So that's going to be pi over 4 plus 5 pi over 4. That is equal to 6 pi over 4. And then we take the 6 pi over 4 times a half. That's going to be 3 pi over 4. 3 pi over 4. Whoops, running out of room. And so then we need the midpoint between 5 pi over 4 and 9 pi over 4. That's going to be 14 pi over 4. So if we take the 14 pi over 4 times a half, that's going to be 7 pi over 4. So that would be 7 pi over 4. And then remember, sine starts out at 0, then it goes to a max, 0, then it goes to its minimum, and then back to 0. And so there's your graph. Okay, so you may have to label amplitude, period, and phase shift, and then you'd have to graph it and label those points. All right, so let's look at this one. Graph y equals the tangent of x plus pi over 2. So to graph the tangent, and keep in mind this problem here, this is graphing it over one cycle. And we're going to graph tangent over one cycle also. So we need 2 adjacent vertical asymptotes. So to find that, you take whatever you're taking the tangent of and you set it equal to negative pi over 2, and this is pi over 2. And you take the x plus pi over 2 and set it equal to pi over 2. Okay. All right. So we solve. So here we're going to subtract pi over 2 to both sides. And so that's going to be x is equal to negative, what was that, pi over? No, that's not pi over 4. That's going to be negative pi. And this one, if we subtract pi over 2 to both sides, that's going to be x equal 0. Whoops. Let's change that back to this color, x equals 0. And so that's what we're graphing the tangent over. Well, let's do this. 0 and negative pi. Now, I showed in the previous problem how to split them up, so I won't show that work in this one. So that's negative pi over 2, that would be negative pi over 4, and this would be negative 3 pi over 4. And so you got a vertical asymptote here, and you got a vertical asymptote here at 0. And we'll call this negative 1 and this positive 1. So remember, as you're going from left to right with tangent, it starts at negative 1 here, then it goes to 0, and then it goes to positive 1. And I know this isn't going to look that good, but it's going to look something like that. All right. All righty, let's look at this one. All right, we want to solve this triangle. So what I like to do here is make a table, angles, sides, And I like to label angle A, we don't know. Angle B is 56.3 degrees. Angle C, we don't know. Side A is 8.3, side B is 7.6, and side C, we don't know. So here you can see we can use the law of sines. And so when we use the law of sines, I'm going to solve for angle A first. So I've got the sine of A over side A is equal to the sine of 56.3 over 7.6. So I get sine A is equal to 8.3 times sine of 56.3 over 7.6. So I'm going to get sine A is equal to, and this we'll have to punch into the calculator, 8.3 times the sine of 56.3, and then that's divided by 7.6, and that's going to give me 0.908581475. And so A is the inverse sine of this number. So I'm doing the inverse sine of 0.908581475. And so if I do the inverse sine of that, that is going to be 65.3 degrees. So that's 65.3 degrees. All right. Now, here's the important part here. All right. Well, it's all important. But notice here we've got sine A is equal to a positive number. Well, this angle we found is in the first quadrant, but sine is also positive in the second quadrant. And so we're using the 65.3 as our reference angle, so 65.3 degrees. We also have to see if this angle works here. So here in the second quadrant, so A would be 180 minus 65.3, and that is equal to 114.7 degrees. So there's a possibility of two triangles. So if we look at 114.7, is that going to work? 114.7 degrees, is that going to work as a angle in the triangle, in our second triangle? Well, angle B was given. So if we take 114 plus 56, is that more than 180? No. So we've got two triangles. If we would have taken this angle plus the given angle here, and that was more than 180, then there's not two triangles. Okay? So we have to make a second table. And let's see, we got 56.3, that's 56.3, that's given. Angle C, we don't know. That's given. B is given. And C. Now, what I like to do, since we have two triangles, we'll label this A1 and C1. And over here, we'll label it A2, C2. Okay? So we'll label this A1 and we'll label this one A2. So real quick, we can go ahead and get C1 and C2. So angle C1. So angle C1 is going to be 180 minus 65.3 minus 56.3. And so C1 is going to be 58.4 degrees. So that's 58.4 degrees. And angle C2 is going to be 180 minus 114.7 minus 56.3. And that is going to be 9 degrees. Okay. And then we can find C1. To find C1, we'll use angle C1 and angle B inside B. So I've got sine of 58.4 degrees over C1 is equal to sine of 56.3 degrees over 7.6. And so C1 moves up. That's going to be 7.6 times sine of 58.4 degrees over sine of 56.3, yeah, 3 degrees. And so for C1, we're going to get 7.8. So that's 7.8. And then you would do for C2, you would do it similar. That's going to be sine of 9 degrees over C2 equals sine of 56.3 degrees over 7.6. And you're going to get C2. I won't show that because, I mean, it's the same as how we did C1. You would get 1.4. And there's your two triangles. All right. All right, now let's look at this one. Let's solve this. So once again, I'm going to make up a table. We've got angles and sides. So angle A, we don't know. Angle B is 10.5 degrees. Angle C, we don't know. Side A is 6.8. Side B, we don't know. And side C is 2.4. All right, so to solve this, you can see here, we cannot use the law of sines. So we're going to have to go and use the law of cosines. And so we're going to solve for side B first. So that's B squared is equal to A squared plus C squared minus 2AC times the cosine of B. So B squared is equal to 6.8 squared plus 2.4 squared minus 2 times 6.8 times 2.4 times cosine of 10.5 degrees. And so we get B squared is equal to, all right, so we get B squared is 19.9065592. And so B is equal to the square root of that, and that's about 4.5. So that's 4.5. All right, so now we can use the law of sines to solve for angle A or angle C. Now, what I want to do here is I'm using the law of sines. I want to solve for the smaller angle first because I know that angle's in the first quadrant. Okay, if we solve for the larger angle first, I don't know if it's in the. I don't know if I need to use the first or second quadrant. There's no possibility of two triangles here, so we're going to solve the smaller one first. And so that's going to be, that's going to be sine of C over 2.4 equals the sine of 10.5 over 4.5. And so, oops, let's see. So we get sine C is equal to 2.4 times sine of 10.5 over 4.5. So I get sine C is equal to, so we'll have to punch this into our calculator. So that's going to be 2.4 times sine of 10.5. And then that's divided by 4.5. And that gives us 0.0971928. So C is the inverse sine of that number, which is, we'll call that 5.6 degrees. All right. And then, of course, angle A, that's just 180 minus the other two angles. And that is going to be 163.9. So that's 163.9 degrees. All right. All right, let's see what we've got now. Okay, we're on the last test now. So we want to solve this. All right, so we're going to solve this for all solutions between 0 and 360. And we're going to solve them for all solutions. So first thing, I've got a sine squared. Well, I want to get this on one side by itself. So I've got, I want to get everything into one side, set it equal to 0. So 2 sine squared x minus square root of 3 sine x equals 0. And so I'm going to factor out a sine. So sine x times times 2 sine x minus square root of 3 equals 0. And we set each one equal to 0. So sine x equals 0, or 2 sine x minus square root of 3 equals 0. So for here, sine x, well, when does that equal 0? Well, if you just look at the basic graph of sine between 0 and 2 pi. It looks like this, doesn't it? Okay, and notice it's 0 at 0 and pi. So x equals 0. We want it in degrees. 0 degrees and 180 degrees. 0 and pi. And now this one, we get sine x is equal to square root of 3 over 2. Okay? And so we get x is equal to what? 60 degrees, because the sine of 60 is square root of 3 over 2. And then we know sine is also positive in the second quadrant. And so we've got to find that. Well, 60 is our reference angle. So x is 180 minus 60, which is 120. So that's 120 degrees. So these are the solutions between 0 and 360. So what if they want all solutions? So if they want all solutions, well, that's just going to be 0 plus 360 times k, 60 plus 360 times k, and then we've got 120 plus 360 times k, and then 180 plus 360 times k. So basically you find your solutions, and then to find all of them, you add a 360k to it. And then that means it just keeps going around forever. So this up here, that's the solutions between 0 and 360. And this is if they ask you for all solutions. Okay. All right. Now, let's look at this one. So they want us to find the exact value of sine alpha minus beta. All right. So the best thing to do here is just write down the formula. So that's going to be sine alpha cosine beta minus well, I mean, you can write it cosine alpha sine beta, or you can write sine beta cosine alpha. It doesn't matter what order you write it in. But notice here that sine alpha, they gave us that, and they gave us cosine beta. So we've got to find cosine alpha and sine beta. Well, let's do that. So we've got sine squared alpha plus cosine squared alpha equals 1. We can use that to solve. All right, so let's see, sine squared alpha, or sine alpha is 3/8. So that's 3/8 squared plus cosine squared equals 1. So that's 9 over 64 plus cosine squared alpha equals 1. Subtract 9 over 64 to both sides. So cosine squared alpha, that's going to be 55 over 64. So cosine alpha is equal to negative square root of 55 over 8, or cosine alpha equals square root of 55 over 8. Remember, it's plus or minus. Well, we can see that alpha is in quadrant 2, so cosine is negative there, so it's the negative solution. And then we'll do the same thing for we need to find sine beta. So we've got sine squared beta plus cosine squared beta equals 1. So we've got sine squared beta plus 12 over 13 squared equals 1. So sine squared beta plus 144 over 169 equals 1. So sine squared beta, we subtract the 144 over 169, that's 25 over 169. And so we get sine beta is equal to negative 5 over 13, or sine beta is equal to positive 5 over 13. And beta is in the fourth quadrant, so we pick the negative one. Sine's negative in the fourth quadrant. All right, so let me erase all of this so we can just erase this part. All right, so now we can plug everything in. So we get sine alpha minus beta is equal to sine alpha. So let's see, sine alpha is 3 over 8. All right, they give us that up here. Cosine beta, which is 12 over 13, minus, and then that's going to be minus cosine alpha, which is negative square root of 55 over 8, times sine beta, which is negative 5 over 13. And so this is going to be 36 over 104 minus, and a minus is positive, and another minus is minus 5 square root of 55 over 104. And so that's 36 minus 5 square root of 5 over 104. And there's your answer. All right, so this is the last problem here. Find the exact value of cosine alpha over 2, and they give you what cosine alpha is. So you've got to know the formula. That's going to be plus or minus the square root of 1 plus cosine alpha over 2. There's your formula. So we've got cosine alpha over 2 equals, now notice this was nice, they gave us cosine, so we don't have to solve for anything, we just plug that in. That's going to be the square root of 1 plus 12 over 13, all that over 2. Now, we've got to figure out which quadrant are we in. All right. Well, notice that 3 pi over 2 is less than alpha less than 2 pi. That's the quadrant that alpha's in, is between 3 pi over 2 and 2 pi. It's in quadrant 4. But we want to know alpha over 2. So if we multiply everything by half, that's 3 pi over 4 less than alpha over 2 less than, or well, it's not or equal to, it's just less than. That's going to be pi. So you can see here alpha over 2 is in the second quadrant, and cosine is what? Negative in the second. So it's the negative. We use the negative, not the plus. All right, now for this is going to be negative square root. Now look at that over 1 and that over 1. So we're going to multiply each term by 13, the common denominator of 1, 13, and 1. So I've got 13 times 1 plus 13 times 12 over 13 over 2 times 13, which is going to be the square root of 13 plus 12 over 26. So that's going to be the square root of 25 over 26, which that's going to be 5 over the square root of 26, and then rational, I wrote a 25, and that's going to be 5 square root of 26 over 26 after you rationalize the denominator. And look what I forgot to do. I forgot to bring my negative with me. But there is a review on the most asked questions. I couldn't do all of them. You can see we're almost up to an hour. But I hope that helped. Check out some other videos. If you need more videos on this kind of stuff, just search my YouTube channel for what you're looking for and you'll probably find it. All right. Well, check out my other videos. Give me a like, share, subscribe, comment. We'll see y'all in the next one. Later.